Good evening, everyone. So welcome to my YouTube channel, Math System. So today we are going to see another important question. If G is any group in which G square is not equal to identity, for some G belongs to G, then G has a non-trivial automorphism. We can say that if G is not a group, if G is a group in which there is an element G whose order is not equal to 2. It means order of G is greater than 2. Then G has a non-trivial automorphism. Okay. So let's see how we'll do it. So there are two possibilities. Either G is abelian or G is non-abelian. Okay. Because G is a group, either it will be abelian group or it will be non-abelian group. So we are taking case first. Case first we are taking G is abelian. G is abelian. Okay. Or you can simply write abelian. So G is a group. It is given. So G is a abelian group. So if G is a abelian group, we know this fact. We know that f x is equal to x inverse is an automorphism of G if and only if G is abelian. We know this fact because we are taking the case in which G is abelian. So this implies that f x is equal to x inverse is an automorphism of G. So we claim that this F is not an identity automorphism. Okay. We claim that F is not equal to identity automorphism. So we will show this by contradiction. Okay. If possible, suppose that F is equal to identity map. If F is identity map, so this implies Fx is equal to Ix for all x belongs to G. But what is the meaning of this? What is the meaning of this? What is x here? Fx, what is the image of x under F? That is x inverse. Because I is the identity map, so this will give Ix only. So we have x inverse is equal to x for all x belongs to G. Now what is the meaning of this? If we will operate x both the sides, this will be xx for all x belongs to G. Okay. So this is identity and this is x square for all x belongs to G. So this implies x square is equal to for all x belongs to G. Okay. So because G belongs to, we know that G, there exists some element. So G is, so this, because this is true for all x belongs to G. So we have G square is equal to G, which is a contradiction. Which is a contradiction to the fact that G square is not equal to I. Therefore, we conclude that F is not equal to identity map. Okay. Hence, in this case, G has a non-trivial. Non-trivial means an automorphism other than identity map. Non-trivial automorphism. So having a non-trivial automorphism, G has a non-trivial automorphism. What does it mean? It means order of automorphism group is greater than 1, because this is a group and group has always identity elements. So it has non-trivial automorphism. It means it has a other map than identity. So its order is greater than 1. Okay. So this is true. In this case, it is true. So second case, we are taking case 2. G is non-abelian group. G is a non-abelian group. Now G, if G is now, we know this fact. If G is abelian, then if we know this fact, we know that G is non-abelian if and only center of G is properly contained in G. Okay. Actually, we have the fact that G is abelian if and only Z is equal to G. So we want to translate it in a contrapositive way. So what is the meaning of that? G is non-abelian if and only Z is not properly contained in G. Okay. It means Z is not equal to G. Okay. So, okay. We also know that inner automorphism group of G is isomorphic to G by Z. Okay. Is isomorphic to G by Z. G by G quotient Z. Okay. Now G is, so from here, since G is non-abelian, we have Z is properly contained in G. Okay. Now Z is properly contained in G. So what we have that order of G by Z is greater than 1. Okay. Okay. Order of G by Z will be greater than 1. Okay. Since as inner automorphism group is isomorphic to G by Z, so this implies order of inner automorphism G is equal to order of G by Z. Okay, that is greater than 1. So this implies order of inner automorphism of G is greater than. Okay. Now we know that inner automorphism is containing automorphism group. Okay. So we get order of automorphism group G is greater than equal to order of inner automorphism group of, and this is greater than 1. So what does it mean? It means automorphism group G has a greater order greater than 1. Okay. So what does it mean? It means G has a non-trivial automorphism. Okay. And therefore, in this case, G has a non-trivial automorphism. Okay. In either case, we have shown that G has a non-trivial automorphism. Finally, it is proved that G has a non-trivial automorphism. Okay, so it is finally proved. So today's lecture up to this. If you have any problems related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you next lecture.